All right, let's see. Yes, I can put this in present mode. Okay, so today your learning target, and the learning target is something I read every day because it's important for you to know what the point is, what you're learning. So today your learning target is today I will learn about Pangea and the theory of continental drift. So today we're focused on learning about what in the world Pangea is and what continental drift is. Although you've probably at least heard of continental drift before because of the movies Ice Age. So that might not be a brand new word to you. If you look up at the picture that I have, that is kind of a summary of what we're going to be talking about today. So some of y'all might be like, is that real? The continents are moving in that picture. Yep, that's what we're talking about today. The continents moving. Okay, so before I get too far on that, before we take our notes, today is your first day of using a paper notebook. Yay, no more digital notebooks. No more waiting 10 years for it to load on your Chromebook. So we're going to have a paper notebook. All I've done to set up my notebook is put my name on the front cover. You want this to be for science only, so I put science notebook. And then on the inside, I put my name again. I just chose second period, but if I was you, I'd put like section 31, section 32. And then I went ahead and made 4, so like this is the back of the first page. So 1, and then 2, and then I left these 2 blank before I got to my notes. So I skipped all the way to the next right-hand side. So let me show you again. The very first page is my name, and then I left 2 pages for table of contents. So if you pause this video right now, you can catch up with me. You can put your name and make a table of contents. And page 1 is going to be titled Evidence of Continental Drift. All right, so you can pause this video and get your notebook set up. And I don't know why I'm pausing. You pause your video, then press play, so I don't need to pause. All right, so notebook set up. I put 1 page of table of contents, 1 more page of table of contents over here, and then I left the next front and back blank just in case. And then I'm going to be starting on the next right hand. So my page number 1 is going to be on the right hand side. So, all right, before we write anything else in our notebook, let's learn. Let's have a little bit of story time. So today we are learning nothing about chemistry. We're on a whole new topic. Remember, we're focused on the word Pangea and continental drift. So to learn about that, I have a little story for you. It's about this guy named Alfred Wegener. He's from Germany, so really I think the real way you pronounce it is Alfred Wegener. I think so. I think that's a German way to pronounce it. He was a German meteorologist. Meteorologist means he studies like weather and things. And by the way, in his day and age, a lot of people thought he was a good-looking man. Not my type, but you know, that's what a lot of people thought. So anyways, he was a meteorologist and he had some fans. But he proposed something about the continents called continental drift. And he proposed that the continents were once all in this supercontinent called Pangea. Say Pangea. So the supercontinent called Pangea, he said every continent used to be smashed together into this mega supercontinent. And ever since then, they've just been drifting apart. He said like this, hence continental drift. So here's Pangea. I love the name Pangea, but here's Pangea 225 million years ago. And then he's saying slowly over time, the continents kept separating and separating until we got to the Earth that we have today. So he's just saying the continents drifted apart. So at first, the other scientists were like, dude, you are a meteorologist. You go talk about the weather. You don't know what you're talking about. And he's like, no, I'm onto something. I've got something genius. And so they're like, okay, prove it. So he started giving some evidence. He had to go and find some evidence. His first piece of evidence was he said that, look, the continents fit together like puzzle pieces. They fit together like puzzle pieces. And to be honest, if you line them up the way he said, they do look like they fit together pretty well. Remember, it won't be exact because weathering, erosion, things get broken down. But they really kind of do look like they fit together. So the other scientists are like, maybe, but that's not good enough. In science, whatever your theory is, it has to be proven. So a group of scientists has to agree with you. So you have to have evidence. And right now, this is just a guess. He can't prove that they were together yet. So next piece of evidence. I do think this one's pretty interesting. Evidence number 2 is matching fossils across continents. So this is interesting because South America and Africa, they might have fossils of animals on both of their continents, but that animal couldn't have traveled across the water. And here's the crazier thing. That animal might not even, let's do a better example. Let's go to Antarctica in India. I know y'all know Antarctica is freezing. That's why I said this would be a better example. So I know you know that this little animal that's on Antarctica could not also survive in India and Africa because now they have totally different climates. Africa is much warmer, so is India, than Antarctica. So when they found fossils of this animal in Antarctica that's also in India and Africa, they're like, how? How is it ever here? Antarctica is freezing. So what Alfred Wegener is saying is that the only way that fossil would be on Antarctica is if the continents used to be connected. If Antarctica was further up and not so far south, and if the animals could walk from continent to continent, because right now our continents are separated by water. If that animal can't swim, it can't get to the different continents. So Alfred's saying, all right, if all these continents were together, then the animals could just travel from continent to continent. Right? Are you convinced? Do you believe him? Scientists didn't believe him yet. They're like, yeah, that's pretty good, but you don't got me. So let's go to evidence number 3. I'm not gonna lie, this one's pretty good too. He pointed out that there's matching mountain ranges and rocks across continents, meaning that over here in North America, you can tell this is Florida. So Texas is somewhere over here if you don't know your geography. Over here in North America, these are the Appalachian Mountains. And there is a similar mountain range in Africa where Alfred Wegener says we used to fit together. I don't know if y'all know this, but ranges, there's different types of mountain ranges based on the mountain formation, the trees, etc. So these two types of mountain ranges are similar. It looks like they could have once been together. Same thing up here. These mountains look like they were all together, and it looks like they've just been pulled apart. The scientists are like, maybe, but that could be chance. You could just maybe have the same mountains on each side of the water. Alfred is like, no, they had to be together. And then they were separated. So he's got one more piece of evidence. Last evidence, matching climate clues across continents. What does that mean? That means that there's evidence of, oops, can you see my mouse? Okay, down here. There's evidence that there was once glaciers on Africa, South America, India, which there's no glaciers on Africa anymore. There's no glaciers on India or Australia. Nope. But you know from weathering and erosion that if there was a glacier on a continent, it leaves evidence. You can see in the ground, you can see in the rocks where there would be evidence that there once was a glacier. I think that's kind of crazy. How is there evidence that there was a glacier on India or Australia if they were never further down on the globe? How? They're so hot now. You think Australia, you think hot. I think Australia, I think kangaroos. Ain't no kangaroos in the glaciers. No. So that is kind of crazy to me. I'm with Alfred right now. So I want y'all to think to yourself, because you can't tell me. I want you to think to yourself, which piece of evidence was most convincing to you? Was it the puzzle pieces? Was it the climate evidence? Was it the fossil evidence? Was it the matching mountain ranges? Which one convinced you? Or are you not convinced? For me, I don't know. I honestly change my mind every year. A lot of times I say the puzzle pieces because it is pretty crazy how they fit together. But I think this year I'm going to say the climate evidence. I don't know how there was ever glaciers on Australia unless Australia was further south or India. So that one kind of blows my mind. So Alfred, he gave all this evidence to the group of scientists. Look, they laughed at him because when they asked him, okay, you've got this evidence, but how did the continents move? He said the continents plowed through ocean crust, moved by tides. So let me make sure you understand. He gave this great evidence. They asked him, all right, but how did they move? He's like, oh, the tides. The tides pulled the continents across the ocean crust. Geologists, people who study the land, they laughed at him. Like literally, you can look this up. They laughed him out the building. Like they just laughed at him. They're like, no, go back to studying weather. You are wrong. So unfortunately, Alfred was a little sad. Alfred went on a tour trek thing. He went to study stuff in Greenland. And y'all know Greenland isn't green and Iceland isn't ice. Greenland is icy. So he's in Greenland. It's freezing cold. And sadly enough, this is sad, Alfred Wegener froze to death. He froze in the ice in Greenland. And that is how he died. He froze being the laughing stock. So that's sad. That's the end of Alfred Wegener's story. But that's not the end of our story today. So years later, another scientist named Harry Hess came to answer the question that Alfred could not answer. Alfred could not say how the continents moved. He had great evidence, but he couldn't say the how. He was missing the how. So Harry Hess discovered seafloor spreading. I don't know if y'all have heard of this or not, but it's actually really cool. There are places in the ocean crust where lava comes up. That shouldn't be too crazy to you because you know that Hawaii was formed from volcanoes, from lava. So there are places where lava comes up. And what Harry Hess did is he measured, you see how there's like a line down the middle of this? He measured this crust that is near that crack, and that crust was really new. It was new crust. And he kept measuring the age because people who studied geology for life, they can measure the age of rocks. That's not my skill, but they can. He measured the age of the rocks further and further out. And the further out he got from the cracks, the crack in the center, the older the crust got. So it's kind of like a conveyor belt. like a conveyor belt, like what you put your luggage on at the airport. You put your luggage and it just pulls it. This is the newest crust, and it keeps moving out. So the continents are sitting on a conveyor belt that's moving away. And that was evidence number 5. That's the last piece of evidence needed. So poor frozen Alfred Wegener, if he had only stayed alive, he would have found out that Harry Hess proved his theory to be correct. Unfortunately, he was already gone. So that is the story of continental drift. That is the whole theory, and that is what happened. Now we are going to, come on, computer. All right, we are going to complete our notes. So what you want to do is pause this video and title your notes Evidence of Continental Drift on page 1, and then trace your hand. You can do it in pencil. I just like colorful pens. But trace your hand, and we don't want any like little skinny twig fingers. We're going to write in the fingers. So I need some fat fingers, y'all. My thumb is not this big in real life. It's not, I promise. But I traced it big. So give yourself some fat fingers and set your notebook up like this. So pause it, set your notebook up. All right, so your notebook should be set up. And now we're going to fill in our notes. So let's think back. The first piece of evidence is going to go in finger number 1. I got to turn my paper to right. Sorry, y'all. The first piece of evidence was that the continents fit together like puzzle pieces called Pangea. First piece of evidence. The continents fit together like puzzle pieces. We called it Pangea. The second piece of evidence he presented was fossil evidence. I don't know, that one's pretty good. I don't know how there's ever mammals that are small and not hairy on Antarctica because they would have frozen to death. So it's a pretty good piece of evidence right there. The third piece of evidence was the matching mountain ranges and rocks. Matching mountain ranges and rocks. Remember, we have mountains in North America that are very similar to the mountains in Africa. It looks like they line up. The fourth piece of evidence is climate clues. And remember, I picked this one as my most convincing one. I think the fact that there's evidence that there was glaciers in India, Africa, Australia, I think that is really convincing. That's kind of crazy to me. So these 4 pieces of evidence are all evidence that Alfred Wegener found. He did all this work. Alfred Wegener. These are all the pieces of evidence that he found. But remember, poor Alfred Wegener froze to death in Greenland. So Harry Hess came to the rescue, and he found the final piece of evidence, which was the how. Sea floor spreading. This is how the plates were moving, by sea floor spreading. So this piece of evidence was done by Harry Hess. It's kind of a cool name too, Harry Hess. And this piece of evidence, we need to draw a little picture underneath it. So what we're going to do is we're going to draw two little plates, like tectonic plates, like crust on the earth. We're drawing crust plates. I'm trying to help you remember from 6th grade. And you know what? Well, I'll leave them in pink. So the plates are moving outward while new lava is coming up to form new crust. Coming up from down here. And what happens is the magma that's underneath the crust, it makes a circle. You saw this in your warm-up. It makes a circle because hot magma rises and cold magma falls. Hot magma rises. I should say cool, not cold. No magma is cold. Cool magma falls. So it makes a circular motion that pushes these plates like a conveyor belt. So I want to label one last thing. This right here is new crust, and on the outside is old crust. All right, that is our notes. Let me see if I can zoom out so you can see the whole thing. I don't know, let's see. Pretty much. That is our notes on the evidence of continental drift, Alfred Wegener, Harry Hess, and what they found. So good job, y'all.